4.4, solving quadratic equations with a quadratic formula. So we've looked at different ways of solving equations. We can do it graphically. We can look at the roots or the x-intercepts. We can factor, or we can complete the square. And the final way is using this quadratic formula. In the next video, I will show you how the quadratic formula was created or how to prove it, which you will have to do on exam. But right now, we're just going to learn how to use it. So this is the quadratic formula right here. We're on page 172 if you want to follow along. It's x, or the roots, are equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And that seems like it doesn't make a lot of sense, like what are a, b, and c? But a, b, and c come from our quadratic equation when it's in standard form. That a value, that b value, and that c value. Okay? So all you do to use the quadratic formula to solve a quadratic equation is you put your equation in standard form, and then you decide what a, b, and c are, plug it in, and it spits out the answer. Seems easy? However, there's some negatives and some squarings that always mess people up. So you have to be very careful about this. The good thing is, once you get a root, every exam, every assignment in this section, you can check. You can plug your answers back into the original equation to make sure you've gotten the right answer. And that's even easier with a graphing calculator, right? So there's no reason that you should hand in anything that you don't know for certain if it is correct or wrong or incorrect. Okay, within that quadratic equation, underneath the square root sign, this part right here is something called the discriminant. And the discriminant isn't something bad that you're not allowed to do in school. It is that is what that expression is called. Okay, and I'm just going to flash forward here. The discriminant tells us how many roots there are. So if the discriminant is positive, greater than 0, there's 2 roots. If it equals 0, there's just 1 root. And if it's less than 0, there's no roots. There's no real roots. There's something called imaginary roots, which we don't know about yet. And that makes sense, because if we take the square root of a positive number like 16, then we're going to get plus or minus 4. Okay, that's fine. That's going to give us 2 answers, whatever we get in the rest of the equation. However, if you get 0 there, you get a number plus or minus 0 over 2a, well then you're just going to get 1 root. And then finally, if you get the square root of negative 16, well, we don't know what that is. There's no 2 numbers that, or there's no number that multiplied by itself gives you negative 16 that we know of. Okay, so let's start here. So this is determine the nature of the roots for each quadratic equation. Check your answer. Okay, note that the question does not ask you to determine, it just asks you how many roots they are. So careful here, this is actually not a lot of work. All we're doing is we're looking at the discriminant. And remember that the discriminant is b squared minus 4ac. So here, we're doing b squared minus 4ac. Question A, we have 5, negative 7, and 4 as our a, b, and c. So b squared would be negative 7 squared minus 4 times a, which is 5, times c, which is 4. So we get 49 minus 20 times 4, which would be minus 80. Well, this is obviously going to be less than 0. So looking back to our sheet here, when we have the discriminant as less than 0, there are no real roots. How could we check this, you're asking? Well, you know what? I would plug this into my graphing calculator, and I would look and see that this actually did not cross the x-axis. Okay, and you can see right here where I have it graphed, y equals 5x squared minus 7x plus 4. It, in fact, doesn't have any real roots. There's no times that it crosses the x-axis. Our next question is trying to trick us. What we must first do in question B is put it into standard form. We must bring everything over to the left side. So we get x squared plus 6x plus 8, and that means that our value of b is in fact positive. Okay, so putting that into our formula, b squared is 6 squared is 36 minus 4 times 1 times 8. 36 minus 32 is going to be greater than 0. We flip back to our page that tells us everything. If it's greater than 0, we have two distinct real roots. And let's just double check that. I graphed it, I believe, over here. And look, x squared plus 6x plus 8, there are two real roots. Okay, I will let you do question C in your book, and we'll move on to the next example. So we use the quadratic formula to solve each of the following. Express your answers in exact values. What exact values means is, I've lost a marker here. What exact values means is that the square root of 2 is more exact than any decimal you can give me, because any decimal you give me does not represent the fact that this is irrational, and it goes on forever. The decimals go on forever. So we always want to put it in exact values like that. So we're going to have to use some of our rational skills here. Our irrational skills, our radical skills rather. Okay, use the quadratic formula to solve each of the following. The first thing we have to do for A is we have to bring the 1 over. Okay, now we're just putting it into the formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And I write it out each and every time just so I remember and I don't make any mistakes. Negative b, so I have negative 6 plus or minus the square root of b squared. Well, that's negative 6 squared minus 4 times a, which is 1. Don't think that there's a 0 there. There's an imaginary 1. 4a times c, which is negative 1, all divided by 2 times 1. Now we're doing algebra. Okay, negative 6 is positive 6, plus or minus the square root of 36, minus 4 times 1 times negative 1, 2 negatives make a positive, plus 4, all divided by 2. Okay, this is 6 plus or minus the square root of 40 divided by 2. We can simplify 40. Okay, what I can do is I can say the square root of 40 is same as the square root of 4 times 10. So sometimes it might be valuable to keep a table of perfect squares. We know that it's 1, so we're going for 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Keeping these somewhere and in your mind is a good idea, and always checking whatever is underneath that radical sign if one of these perfect squares are factors. It doesn't matter if these are factors, it's only the perfect squares that you need to be looking at. Okay, so I go 6 plus or minus, well the square root of 4 is 2, so I can put 2 outside and then I can put square root of 10 all divided by 2. Well, I can divide each of these by 2 and I get 3 plus or minus the square root of 10. So my answers for x are 3 plus root 10 and 3 minus root 10. Okay, those are my two answers. It is important that you do this step of simplifying. And it doesn't matter if you take out a perfect square and then you take out another perfect square later. Sometimes it's not always important that you get that biggest perfect square to factor right away. Sometimes it can come later. And that's just going to come with practice. Okay, let's try the next one here. So again, in question B, I am going to have to rewrite this in the correct way. I have to go 3x squared minus 8x plus 3 is equal to 0. And then I'm going to do the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And now I'm just subbing in. X is equal to negative b, so that's negative 8, plus or minus the square root of negative 8 squared minus 4 times 3, because that's a and my c is 3. All divided by 2 times 3. Okay, now I'm just doing algebra. X is equal to 8 plus or minus the square root of 64 minus 4 times 3. Did I do that right? Is there 2 3's in here? Oh, there is. Okay, 4 times 3 is 12. 12 times 3 is 36, all divided by 6. So now all I'm going to do here is I'm going to simplify 64 minus 36. Okay, so that's 28. Oops. Now I have to look at the number 28 and I have to think of perfect squares that will go into that. Well, I know that 4 would. I'm going to try that first of all. 8 plus or minus the square root of 4 times, is it 6? No, 4 times 7 is 28. All divided by 6. Okay, the square root of 4 is 2, so I can put a 2 outside of the square root. So it's 2 root 7 is the same as the square root of 28. And if you're ever worried you haven't done this right, you could just enter them both in your calculator and just double check that they come to the same decimal. Sometimes that's a good trick when you're checking your work on a test or an assignment. Make sure that you've done that correctly. Okay, so I can divide everything by 2. So I get 4, 3, and 1. So I get 4 plus or minus the square root of 7 over 3. So my answers are x equals 4 plus the square root of 7 over 3, and x equals 4 minus the square root of 7, all divided by 3.